Welcome boys, welcome to Higher Mathematics class. Today I am Shudipan Bhattacharya going to discuss about logs and indices in this class. Today we are going to discuss about specially indices. Today's topics are uh, working rules of indices and solved problems related to indices. So let's see the working rules of indices, how indices work. Working rules of indices. Firstly, we have to remember that if we found 0 as index of some variable or number, then we will write 1. That is a to the power 0 equal to 1. For example, 5 to the power 0 equal to 1. Then you know this very well. A to the power x into b to the power x equal to ab whole to the power x. Look at these expressions. Uh, we have same indices uh, as the we have same indices for a and b, so we can take the index common. If we find some expression in which uh, two two expressions are multiplied and their index are same, then we can multiply the bases first, then we can put the index over the expression, like a to the power x, b to the power x equal to a to the power x into b to the power x equal to ab to the power x, ab whole to the power x. Remember that if there were a plus sign here, we could not do this. Uh, we could not write this like this. So, for example, we can say 3x whole cube equal to 27x cube. That is 3 cube, 27 and x cube. And also zx to the power 5 equal to z to the power 5 into x to the power 5. So whatever you can write this for indices. For third rule, we will learn that if the bases are same, then uh, and then when they are multiplied, if the bases are same, when they are multiplied, the powers will be added. That is a to the power x into a to the power y. The powers will be added a to the power x plus y. So when 3 to the power m into 3 to the power n, you can write 3 to the power m plus n. And also 3 to the power half into 3 to the power minus 1, you will write half plus minus 1, that is half minus 1. You will have 3 to the power minus half. This is minus half. Okay. For fourth rule, we will have a to the power x by a to the power y. If two expressions are divided, then if their bases are same, a to the power x and a to the power y, both of the denominator and numerator, we have base a. So if you have the same base uh, and the powers, if they are divided, if the expressions are divided, then the powers will be subtracted from numerator's power to denominator's power. So x minus y will be here. So for example, x to the power 4 by x to the power 3, you can write 4 minus 3, x to the power 4 minus 3, and you can write x to the power 1, and that is x. And also x to the power half divided by x to the power 4 by 3, you can write x to the power half minus 4 by 3, that results x to the power 3 minus 8 by 6, and equal to x to the power minus 5 by 6. So here we have to note that a cannot be 0 here, because if a is 0, then this expression will be undefined, and therefore for this rule we have to keep in mind that to apply this rule, a cannot be 0. Then rule 4 5 sorry rule 5 is a to the power minus x. Whenever we have a negative power or a negated power, we have to take the power as 1 by, like a to the power minus 1 equal to 1 by a to the power x. For example, a to the power minus 1 equal to 1 by a, and a to the x to the power minus 5 by 6, you will write it a to the power 1 by x to the power 5 by 6. That is, to remove the negation or negative sign, we have to write it 1 by uh, the expression, 1 by the positive powered expression. So a to the power minus x, the minus is removed by inversing it. Then 6, for root 6 you will get a to the power 1 by x. If a fraction power is over any variable or number, then you will have to write that 1 by x, that is 1 by x, xth root of a. Xth root means if you have 2 to the power 1 by 3, then it will be cubic root of 2. And if you have 3 to the power minus half, then you know, to remove the minus sign we will take it under 1. Therefore 1 by 3 to the power half, and it will be 1 by root 3 square root, because 1 by x, whenever we get 1 by x, then xth root will be applicable. So here 1 by 2, so second root, that is square root, is applicable here. Here 1 by 3, so we will write third root of, that is cube root of 2. And we have to note for these two rules that here a cannot be 0, because 1 by a to the power x, and a cannot be 0. If a is 0, then the term will be undefined, the both term will be undefined. And here look at this expression, if x is even, then we will get square root or something like the square root, fourth root, and then a have to be greater than or equal to 0. A cannot be negative number, because whenever we will put a to the power half, we will have the square root or fourth root, and we know that we cannot apply square root or fourth root over a negative number when we are dealing with real numbers. So whenever a is real, or we are working with real numbers, a cannot be less than 0, that is a is greater than or equal to 0. And the final rule is a to the power x whole to the power y equal to a to the power xy. Say power over power, that is, you have an expression with some index, and there is another index over the expression, then we will simply multiply the expressions. Look, we have put a bracket here. If we didn't put the bracket here, then we could not write this expression. So a to the power x whole to the power y equal to a to the power xy. For example, 3 to the power 5 by 2 whole to the power half. What we would write? We will write multiplying these two powers, that is 5 ones are 5 and 2 twos are 4. That is 3 to the power 5 by 4. And if we have 2 cube whole to the power 1 by 9, then we will have 2 to the power 3 by 9, that is 3 by 9, that is 1 by 3. So I hope that you could understand the rules for indices, and now we are going to solve some examples that will be to master the rules. So let us see some solved problems on indices. Problem 1. Prove that uh, problem 1, we have to prove that a cube plus a to the power minus 3 plus 1 divided by a to the power 3 by 2 plus a to the power minus 3 by 2 plus 1 equal to a to the power 3 by 2 plus a to the power minus 3 by 2 minus 1. So we have to prove this identity. So solution, look at here how to prove that. The easy way to prove that, we know from the left hand side somehow we will get the right hand side. So when left hand side will be expressed in something, uh, that is, left hand side is a fraction and right hand side is not a fraction. So we will multiply the expression of the right hand side uh, with both numerator and denominator, then we'll get an expression. So we start with left hand side, left side equal to what is given, or so we have multiplied the expression of right hand side on both with both numerator and denominator. So then look at numerator, a to the power 3, denominator, look at the denominator, a to the power 3 by 2 plus a to the power minus 3 by 2 plus 1, and here the expression is same but minus 1 is here. So we can apply a plus b into a minus b, where a is a to the power 3 by 2 plus a to the power minus 3 by 2, that is a, and 1 is b. Then we can write that a plus b into a minus b. So using this formula we can write a square minus b square, that is uh, a to the power 3 by 2 plus a to the power minus 3 by 2 whole square minus 1 square. And we will keep unchanged, we will keep the numerator unchanged, because in the numerator we will get this expression as our right hand side. So we need to keep as it is. So then when whole square comes, so I will write this using the formula a square plus 2ab plus b square, that is a to the power 3 by 2 plus a to the power minus 3 by 2 whole square, that is a square plus 2ab plus b square, and minus 1 whole square, that is carried here. And also the denominator is changed but numerator will be unchanged. So now a to the power 3 by 2 whole square means the index and the powers over power, square over 3 by 2. So these 2 and 3 by 2 will be multiplied and it will be resulted as a to the power 3. We know that when power is over some power, then powers are multiplied. So 2 into, as denominator we get a cube from this expression, and 2 into a into, look here, here bases are same, a and a, so powers will be added. So 2 into a to the power 3 by 2 minus 3 by 2, and here a to the power minus 3 by 2, minus 3 by 2 and 2 as a product they will give minus 3. So a to the power minus 3 and minus 1 whole square is carried here. Now we'll get denominator, numerator as same, and denominator, in the denominator we will get a cube plus 2 into a to the power 0 into 1 plus a to the power 0 means 1, here 1 is extra, written as extra 1 here, and a to the power minus 3 and minus 1 square. So then from this we can write a cube plus 2 plus a to the power minus 3 minus 1, because 2 into a to the power 0, 2 into a to the power 0 uh, means 1. A to the power 0 means 1, so 2 into 1 equal to 2. So here we will get 2 and minus 1 whole square. So minus 1 whole square gives us 1. So from this line we can write this. A to as the denominator we get a cube plus a to the power minus 3 plus 1. So which is a common factor in the denominator and numerator. So we will cross this out and we will get a to the power 3 by 2 plus a to the power minus 3 by 2 minus 1, which is the right side. So this was our proof. Now we will get to problem 2. In problem 2, simplify the following expression. So we have an expression here and we have to solve this expression, simplify this expression. So to simplify, when you are going to simplify, so you have to take common and multiply, and like this you have to go on with different activities what to do. Now we know when power comes out here, powers are when the expressions are related with indices or index. So then we have to use the idea of indexes. So look at here, a plus b by b is given here and a plus b by b also given here. So these bases are same but the powers are different, so we will take uh, this as a to a plus b by b, and we will subtract the powers because bases are common. So we know that x by y, x to the power a and divided a to the power x divided by a to the power y equal to a to the power x minus y. So if we look at this expression, so we will get like this. So we'll start solution. Look, this is the given expression, and here we have taken a plus b by b as common base, and we have subtracted the powers a by a minus b and b by a minus b. So this comes out here, and also a minus b by a minus b by a, these two bases are same, so we have subtracted the powers here. So if we subtract the powers, we will get this expression. A minus b will be taken as LCM as denominator, and we will get a minus b over it. And look at here, a minus b divided by a minus b, that is 1. A minus b divided by a minus b, that is 1. So we will get a plus b by b into a minus b by b, a. So from here we can write a square minus b square divided by ab. So whenever we multiply the two fractions, we know what to do. Numerator and numerators will be multiplied, that is a plus b into a minus b. It will be a square minus b square, and denominator are multiplied, so as denominator we will get ab. This is the simplified answer. So next we will go to problem 3. As problem 3, I will write simplify the expression this. So what we have got here, we have got BC root, that is BC is a number, like BC is P, then 3. If BC is 3, then third root of or cube root of this CA root of this expression, and AB is root of this expression. So we have to simplify this. So how to simplify? Solution, write down the expression. Now you know that if we know if we get an root, some root of any expression, then it can be written as fractional power. So we will write this BC as 1 by BC. CA is 1 by BC as index, and AB will be 1 by AB as index. When these roots are expressed as powers, then it become and then they become 1 by the number of root. So like this you can write x to the power b by c divided by x to the power c by b whole to the power 1 by bc. That is bcth root gives us 1 by bc, and you can write it here like this: 1 by ca, 1 by ab. We have converted the roots as powers, fractional powers, and now we can write this, because 1 by bc is a power here and x to the power b by c is a power here. So 1 by bc will be power for numerator and denominator. So it will be multiplied with the power of numerator and also will be multiplied with the power of numerator. So whenever we multiply bc and 1 by bc, then bb will be cancelled and we will get 1 by c square, that is x to the power 1 by c square. And whenever we multiply this power 1 by bc with the power c by b, then c will be cancelled, we will get 1 by b square. Similarly, we write the other terms. Here we have x to the power 1 by a square, x to the power 1 by c square, x to the power 1 by b square, x to the power 1 by a square. Now we have bases as common. X is common base, so we can subtract the powers from here. So we can write like this: x to the power 1 by c square minus 1 by b square, x to the power 1 by a square minus 1 by c square, and x to the power 1 by b square minus 1 by a square. So also here also x to the power, these three terms are multiplied, but 3 this x is the common base for every term. So we can write like this: uh, we have added all the powers because they are multiplied here. We have added the powers: 1 by c square, 1 by b square plus 1 by square. Now we have added the powers: 1 by c square minus 1 by b square plus 1 by a square minus 1 by c square, 1 by b square minus 1 by a square. So look at here, we can have 1 by c square and minus 1 by c square, they will be cancelled and get 0. 1 by b square minus 1 by b square and plus 1 by b square, they will be cancelled and we will get 0. Plus 1 by a square and minus 1 by a square will be cancelled. So we can write that x to the power 0. And we know that something to the power 0 is 1. So this is the simplest value of the given expression. So sometimes it's given that prove that this expression is equal to 1. Sometimes it is given that as simplify the terms. Whatever you have, you can solve this kind of term solution very easily. So let's start another problem. 1 by 1 plus a to the power minus m b to the power n plus a to the power minus m c to the power p plus 1 by 1 plus b to the power minus n c to the power p plus b to the power minus n a to the power m plus 1 by 1 plus c to the power minus p a to the power minus m c to the power minus p b to the power n. So we have to simplify this problem. The solution: So whenever you have this kind of expression, you will have to keep in mind that something is common here, some pattern is here. So we have to deal with the pattern. So look at the first fraction. Here you will have a to the power minus m, also you will have a to the power minus m. So think about it. If we multiply a to the power m, then in numerator and denominator, then we will get a to the power m multiplied with 1, that is a to the power m, and this a to the power minus m will be cancelled a to the power m, and also this a to the power minus m will be cancelled by a to the power m. So we'll write the expression first, then we'll multiply a to the power m uh, with both of the numerator and denominator of the first fraction, and in the second fraction we will multiply b to the power n with denominator and numerator, and at the third fraction we will multiply c to the power p denominator and numerator. So we'll get like this. A to the power m is multiplied in both here, b to the power n is multiplied with denominator and numerator of second, and with denominator and numerator of third expression we will multiply c to the power p. So we'll get it this way, and now you'll get this expression, that is a to the power m is here, a to the power m and a to the power minus m, that is a to the power m minus m, that is a to the power 0, a to the power 0 equal to 1, therefore b to the power n will be remained here. So also a to the power m, a to the power m will be cancelled, being 1, so we will get c to the power p into 1, that is c to the power p, and like this. Similarly, from second and third fraction we will get this type of expressions. Now adding them, the three fractions, we will get a to the power m, b to the power n, c to the power p as the denominator. In three cases we will get the same denominator. So so in the simplified expression, the denominator is a to the power m plus b to the power n plus c to the power p, and as it is added, then we will get a to the power m, b to the power n and c to the power p as the numerator, and also denominator and numerator both will be cancelled, that is 1, both are same. So this is the answer. Now we'll go for problem 5. Problem 5. Simplify this. Uh, we have an expression like this. We have to simplify. What to do now? We have some minus 2 and minus 1 as the indices here. So for our convenience, we will take this negated exponent as 1 by b square, and also we can write this a to the power minus 2 as 1 by a square. Also b to the power minus 1 can be written as 1 by b, and a to the power minus 1 can be written as 1 by a. So as a solution, we will write the given expression first, then we will convert them like this. Here the expression is remains the expression is kept same, but only changed terms are b to the power minus 2, that is 1 by b square, and a to the power minus 2 is converted writing 1 by a square. Also, b to the power minus 1 is written as 1 by b, and a to the power minus 1 is written as 1 by a. Now you will have 1 by b square means 1 by b whole square. Therefore, this expression a square minus 1 by b square might be uh, written as a square minus 1 by b whole square. So we can use a formula here, a square minus b square, that is a plus b into a minus b. So we have written the formula a plus b into a minus b, that is a plus 1 by b into a minus 1 by b. Also in the new denominator we can write b plus 1 by a into b minus 1 by a, and whole to the power a in the numerator, and in the denominator we have the power same whole to the power b. And we have broken down the power here, a minus 1 by b whole to the power b minus a, that means a to the power a minus 1 by b whole to the power b into a minus 1 by b whole to the power minus 1. Also for denominator b plus 1 by a to whole to the power a minus b, that is b plus 1 by a to the power a into b plus 1 by a to the power minus b. Now what is the next line? In the next line, this a is distributed over these two, that is a to the a plus 1 by b whole to the power a and a minus 1 by b whole to the power a. Also this whole to the power b is distributed with the multiplied terms b plus 1 by a whole to the power b and b minus 1 by a whole to the power b, and the remaining are kept as they were. So now we can write this. Look here. A plus 1 by b whole to the power a and a minus 1 by b whole to the power b. What happened to the other ones? Look at here, a to the a minus 1 by b whole to the power a and a minus 1 by b whole to the power minus a. The bases are same here, a minus 1 by b. Here also we have a minus 1 by b, but the powers are a and minus a. So powers are added, a and minus a are added. When they are added, they become 0. A and minus a become 0. So something to the power 0 equal to 1. So a minus 1 by b and a minus 1 by b whole to the power 0, this will become 1. Therefore they are cancelled. Also b minus 1 by a whole to the power b and b plus 1 by b whole to the power minus b, b plus 1 by b whole to the power b and b plus 1 by a whole to the power minus b, they are cancelled. So remaining terms are b minus 1 by a whole to the power b and b plus 1 by a whole to the power a. Now we have to simplify these terms. This term we can find here, there is none of the bases are same, a plus 1 by b, a minus 1 by b, b minus 1 by a, b plus 1 by a. Bases are not same, but we can find same powers here. So a here and also a here. So we can take these two expressions, a plus 1 by b and b plus 1 by a, under the same index a, and also we can take a minus 1 by b and b minus 1 by b under the same index b. Before that, we can add the fractions ab plus 1 divided by b, and from here we will get ab minus 1 divided by b. From here we will get ab minus 1 divided by a and ab plus 1 divided by a. Now we will separate the expression whose powers are a and whose powers are b. So we can write it like this. Look at here, a plus ab plus 1 divided by b and ab plus 1 divided by a, they both have the same power a. so they are separated. And also a minus 1 divided ab minus 1 divided by b and ab minus 1 divided by a, they also have the same power b, so they are separated here. And their relation, what is the relation between this term and this term? They are being divided by each other. ab plus 1 by b divided by ab plus 1 by a. So ab plus 1 by uh, ab plus 1 by b and ab plus 1 by a, they are divided and their power is a. So we have written it like this. And if you divide the two terms, then you will get the same numerator and the different denominator. So by dividing these two expressions, you will get a by b, and also by dividing these two expressions, you will get a by b. So a by b whole to the power a and a by b whole to the power b. So how to divide these expressions, I will not explain this because you have learned division and multiplication, these kind of things in your class 8 textbook. So we will get a by b whole to the power a plus b. This is the most simplified answer. So now we will get next problem, problem 6. If x equal to a to the power qr into b to the power p, y equal to a to the power a to the power x equal to a to the power q plus r b to the power p, y equal to a to the power r plus p b to the power q, and z equal to a to the power p plus q b to the power r, then show that. So I think this will be 0 or something, so we'll get it later. Solution, we have to find out the value of this expression. So it will not be show that, it will be like this: find the value of x to the power q minus r, y to the power r minus p, and z to the power p minus q. And here x to the power a to the power qr into b to the power p, or we can write a to the power x to the power q minus r equal to uh, a to the power q plus r b to the power p whole to the power q minus r. We have taken the power q minus r at the both sides of the expression. So from here, second, from this line we can write q minus r will be distributed over a to the power q plus r and b to the power p. So we will get a to the power q plus r into q minus r, b to the power p into q minus r. So this q minus r, this q minus r is multiplied by q plus r and also multiplied by b to the power p. So now from here you will get a to the power q square minus r square, that is q plus r into q minus r, that is a square minus b square formula, and you will get b to the power pq minus pr by multiplying simply. And this is what we have got as the value of x to the power q minus r. The x to the power q minus r equal to a to the power q square minus r square, b to the power pq minus pr. So again, y to the power r plus p, sorry, a to the power r plus p into b to the power q gives that y to the power r minus p equal to a to the power r plus p into b to the power q whole to the power r minus p. So similar way we have done in the first step, we can get it like this: a to the power r square minus p square into b to the power q r minus pq, just by multiplication, simple multiplication. And also z to the power p minus q will give, we have written it very in short, because we could understand that it will be, when it was r minus p, it became r square minus p square. So when it is p minus q, it will become p square minus q square. And also q is multiplied with r minus p. Here q will be multiplied with p minus q. So r will be multiplied with p minus q. So rp minus rq will be pr, and qr will be pr minus qr will be the index of B. So we have got three values: x to the power q minus r, y to the power r minus p, and z to the power p minus q. So we have to find the value of x to the power q minus r, y to the power r minus p, and z to the power p minus q. So we will multiply this term, three terms, or we will put the value of these terms with in the next step. Therefore, x to the power q minus r, y to the power r minus p, and z to the power p minus q equal to, we have put the value of x, and then we have put the value of y, and then we have put the value of z from our previous steps. So it will be a to the power, look at here, q square minus r square minus p square, and p square minus q square. So a will have the powers added here, because a and these three a are arranged, these three a are multiplied to each other. So a to the power q minus r, q square minus r square minus p square, and p square minus q square will be added, because the bases are same. Also here b and b, the bases are same, so their powers will be added. So powers will be added: pq minus pr, qr minus pq, and pr minus qr, and we will get a to the power 0 and also b to the power 0, because q square and q square will be cancelled, r square cancelled, and p square are cancelled. Here pq and this pq will be cancelled, pr and this pr will be cancelled, qr and this qr will be also cancelled. So the result will be 1. So this was the explanation of problem 4. Here we have to write that, then show that this equal to 1. So now it is okay. Now we'll that is showed. Now we will have problem 7. So what is the problem 7? So here we are given that x cube root a plus y cube root b and z cube root c equal to 0. That is this is an expression, and also another expression is this is an equation, and also another equation is a square equal to bc. We have to use these two equations, and we have to prove that ax cube plus by cube and cz cube equal to 3axyz. So look at this expression. We have to prove ax cube, that is when we'll cube this term, we'll take a cube on this term x cube root a, then we will get ax cube. If we cube this term, second term, then we will get by cube. And if we take the cube of third term, we will get cz cube. So we can understand that we have to start with cubing in this expression. So the solution will be like this. given that x cube root a y cube root b plus z cube root c equal to 0, or x cube root a plus y cube root b equal to minus z cube root c. Now we can take cube of both sides, so we have taken cube of both sides. Then we must know the formula of whole cube. So the formula of whole cube is a cube plus b cube plus 3ab into a plus b. So we will get a cube, that is x cube root a whole cube, plus b cube, that is y cube root b whole cube, plus 3 into a b, that is x cube root a into y cube root b, and a plus b, that is x cube root a plus y cube root b, equal to cube of minus z is minus z cube, and cube root of c to the power cube, that is c. So we will get this line, or we will get x cube a plus y cube b by cubing these two terms. We have taken x cube root of a whole cube, that is x cube, and cube root of a whole cube, that is a. So similarly we can get y cube root b whole cube equal to y cube b. So now 3 into xy are arranged like this, and we have cube root of ab. Look at here, cube root of a and cube root of b, this will give us cube root of ab, and x to a cube root of a plus y cube root of b, this is x cube root of a y cube root of b, this is equal to minus z cube root of c. So we have replaced this x cube root of a plus y cube root of b with minus z cube root of c, and then we will write minus z cube c as the right hand side. So now we are almost there. X cube root of a plus y cube root b minus this minus z is multiplied, so 3xyz and cube root of abc. So 3xyz and cube root of abc and equal to minus z cube c. So you can see that we have already got three terms, ax cube, by cube, cz cube. We can write it ax cube, y cube, by cube, and cz cube. And also we have got this term also 3axyz. So 3xyz, we have to write this abc as a. So we have got bc equal to a square, so we can write this bc is equal to a square. So we will write that x cube a plus y cube b minus 3xyz and a into putting the value of bc is equal to a square equal to minus z cube c, or x cube a plus y cube b minus 3xyz into cube root of a cube. Cube root of a cube means a, and also in the next line we will have x cube a plus y cube b plus uh, z cube c. Taking this z cube c at the left side, we will get this, and minus 3xyz minus 3xyz and cube root of a cube means a equal to 0, or you can write x cube a plus y cube b plus z cube c equal to 3xy axyz. So this is our proof. To write accordingly, you have to write ax cube, by cube, and cz cube, and then 3axyz. So I hope you will do the next line by yourself. So I have written proved here. So now we will go to problem 8. If a square plus 2 equal to 3 to the power 2 by 3 plus 3 to the power minus 2 by 3, then prove that 3a cube plus 9a equal to 8. So 3a cube minus 9a equal to 8. So this is our problem 8. So given that a is greater than or equal to 0, So now as a solution, given that a square plus 2 equal to uh, 3 to the power 2 by 3 plus 3 to the power minus 2 by 3. So you can see that here we have 3a cube. So we have to find out an expression where there is no a square, but there will be a, and then we have to cube these terms. So we will find the value of a from here. A square equal to 3 to the power 2 by 3 plus 3 to the power minus 2 by 3 minus 2, or a square equal to 3 to the power 1 by 3 whole square plus 3 to the power 1 by 3 whole square minus 2 into, we can write 3 to the power 1 by 3 into 3 to the power minus 1 by 3. So this 2 was given, so we have written 2, and as we want to put it in a formula, so we can see that by observation, 3 to the power 1 by 3 and 3 to the power minus 1 by 3, if they are multiplied, then the power will be added and the sum of the powers will be 0. So 3 to the power 1 by 3 into 3 to the power minus 1 by 3 results 1. Therefore we can write 3 to the power 1 by 3 and 3 to the power minus 1 by 3, which will not change the value of 2. This term is equal to 2. But what is the benefit here? By writing this, we can express this expression as a formula of a square plus 2ab plus b square. So we can write it in a form a square minus 2ab plus b square. So we can write it like this: a minus b whole square, that is 3 to the power 1 by 3 minus 3 to the power minus 1 by 3 whole square. So as a is greater than or equal to 0, we can write that a is equal to 3 to the power 1 by 3 minus 3 to the power 1 by 3. So we can write this a equal to 3 to the power 1 by 3 minus 3 to the power minus 1 by 3. So we don't have to take plus minus here, and we will keep 1 by 3 at first and 3 to the power minus 1 by 3 at as the second term, negative 1. And because if we put 3 to the power minus 1 by 3 in front and then minus 1 minus 3 to the power 1 by 3, if we would take this, if we would take like 3 to the power minus 1 by 3 minus 3 to the power 1 by 3 here, then a would be less than 0. So we have put the greater term at the as the positive one, and uh, smaller term as the negative one. So then we can take cube at the both sides. A cube equal to 3 to the power 1 by 3 minus 3 to the power minus 1 by 3 whole cube, or a cube equal to 3 to the power, the formula of a cube a minus b whole cube is a cube minus b cube minus 3ab into a minus b. This was the formula: a cube of a minus b whole cube, a cube minus b cube minus 3ab into a minus b, that is 3 to the power 1 by 3 whole cube minus 3 to the power minus 1 by 3 whole cube minus 3 to the power 1 by 3 into 3 to the power minus 1 by 3 into 3 to the power 1 by 3 minus 3 to the power minus 1 by 3. So we can write it a cube 3 to the power 1 by 3 whole to the power 3, that is when there 1 by 3 and 3 are multiplied, it will be 1. 3 to the power 1, 3 to the power minus 1, 3 to the power, here power of 3 is 1, here power of 3 is 1 by 3, and power of 3 is 1 minus 1 by 3. If we add them, we will get 3 to the power 1 plus 1 by 3 minus 1 by 3, and also the value of 3 to the power 1 by 3 minus 3 to the power minus 1 by 3 is a. So we will put an a as the value of 3 to the power 1 by 3 minus 3 to the power minus 1 by 3. Now a cube equal to 3 to the power 1 equal to 3. minus 1 by 3 minus look at here, 3 to the power 1 by 3 and 1 by 3 they are cancelled, therefore there will be 3 here, 3a. Now if I multiply both sides with 3, we'll get sorry, we have taken and the minus 3 at the left side, and we will take the LCM of these two fractions, 9 minus 1 by 3. Now adding the fractions, we will get 9 minus 1 by 3 here, and then if we multiply by 3 in both sides, we will get 3a cube plus 9a, and 9 minus 1 equal to 8 here. So here is it which was targeted to prove. So we have proved that 3a cube plus 9a equal to 8. 3a cube plus 9a equal to 8. That was to prove. So now we'll go to problem 9. Let's see what problem 9 says. If b equal to 1 plus 3 to the power 2 by 3 plus 3 to the power 1 by 3, prove that b cube minus 3b square minus 6b minus 4 equal to 0. This is also the same kind of math. You can see here I already have b here, so we don't need to we just need to find out the whole cube of b. So it will be better if we take two terms at one side and then take cube. So proof, given that b minus 1 equal to given that b equal to 1 plus 3 to the power 2 by 3 and plus 3 to the power 1 by 3. So we have taken this 1 at the left side and we will get b minus 1 here. So then we can take cube at the both sides. If we would not take this minus 1 at the left side, we would have three terms at same side, and therefore if we are going to cube them, then it will be very expanded, or it will become very big. The right side will become very big expression. So we would have to mm, take this one at the left side. Then taking cube at both sides, we can write 3 to the power 2 by 3 whole cube plus 3 to the power 1 by 3 whole cube, a cube plus b cube plus 3ab into a plus b. This is we have to write. Now look at this 3 to the power 2 by 3 plus 3 to the power minus 1 by 3. The value of 3 to the power 2 by 3 and 3 to the power minus 1 by, there will not supposed to be minus here. So at the next line we have to write a cube plus b cube plus 3ab into a plus b, but this 3 to the power 2 by 3 and 1 by 3 means b minus 1, so we will put the value b minus 1 here. Now we will get b cube minus 3b square plus 3b minus 1 using the formula b cube a cube minus 3a square b plus 3ab square plus minus 1. The formula becomes this expression, and at the right side we will get 3 to the power 2, 3 to the power 1, 3 to the power 1 plus 2 by 3 plus 1 by 3 into b minus 1. This is what we have here. And then b cube minus 3b square plus 3b minus 1 equal to 3 square equal to 9, 3 to the power 1, so 3 to the 1 plus 2 by 3 and 1 by 3. If we add the terms, then we will get 2, then b minus 1. So now we have to just simplify this. 3b square plus 3b minus 1 equal to 12 plus 9 into b minus 9, or we write this, or taking all of the terms at the left side we will have this, and now we will write b cube 3b square minus 3b and 9b, that is 6b minus 4 equal to 0. 12 and 1 is minus 13, and plus 9 equal to 4 minus 4. So this was to prove, so we have successfully proved this. We have to just remember that here we will have 3 to the power 1 by 3. So this is the solution. Is equal to 0, then show that this. Now we have to take the left side and we have to prove that the value of left side equal to 1. In this math we will not have, we cannot multiply by watching this. We have to use some special technique. So solution, look at here, as it is given that a plus b plus c equal to 0, therefore you can write a plus b equal to minus c, or b plus c equal to minus a, or c plus a equal to minus b. So if we take b at the right side, a, then we will get a plus c is equal to minus b, and thus sum of 2 will be negative of the third one. So now the given expression is this, left hand side equal to, look at here, we have just converted this x to the power minus c like this, 1 by x to the power c. X to the minus a, we have written it 1 by x to the power a, and x to the minus b, we have written it 1 by x to the power b. The remaining are same. So if we take the LCM here, we will take LCM of 2, we will take LCM of the first denominator, x to the power c, and we will get x to the power b plus c plus 1 plus x to the power c. And we will take LCM here, x to the power a, and when added we will get x to the power a plus c plus 1 plus x to the power a, and we will not convert the third one. Now we can write them like this. Look at here, x to the power b plus c means x to the power minus a, x to the power a plus c means x to the power minus b, and x to the power minus b is here also. And also this is the x to the power minus c, x to the power c. What happened to this x to the power c? As it is denominator of the denominator, so when it is divided by 1, the term will be flipped. So x to the power c will be going to numerator, and the numerator of the denominator will become the denominator of the new fraction. So here also, when a, x to the power a plus c plus 1 plus x to the power a is flipped, then x to the power a will be the numerator, and the remaining one is okay, same. Now you can write it like this. You can multiply x to the power a in both numerator and denominator, because you have get x to the power minus b here, you have get x to the power minus b here, 1 here and 1 here, a here and x to the power a here. So these two denominators are same. So we want to make this denominator also same as the remaining two. So if we multiply x to the power a here, then we will get x to the power a and x to the power a cancelled. We will get 1 multiplied with x to the power a, we will get x to the power a, and x is multiplied with x to the power c, that is a plus c, that will become minus b. So we want to find out the minus b, and we already have c as x to the power c. So to get this minus b, we need c and a, c plus a. So if we multiply a, x to the power a, in both numerator and denominator, then it will become c plus a, that is minus b. So this is our technique. So we can write it like this. The remaining two are same. The first one will be changed like this: x to the power a plus c, x to the power a and x to the power minus a become 1. 1 into x to the power a, x to the power a, x to the power c into x to the power a, that is x to the power a plus c. So next what we have to do is x to the power minus b. A plus c is minus b, so x to the power minus b, x to the power a, x to the power a, 1 here. And look at the denominators. Here a plus c means minus b. Therefore we have got all the denominators same: 1 x to the power a, x to the power minus b, 1 x to the power a, x to the power minus b, 1 x to the power a, x to the power minus b. So denominators are same, so the LCM will be the common denominator 1 plus x to the power a, x to the power minus b, and the numerators will be added simply. So we'll write x to the power b plus x to the power a plus 1 as the numerator, and the denominator is obvious. Now look at here, denominator and numerator are same. So if in a fraction the denominator and numerators are identical, then the value is 1. So this is how we have proved that uh, the given expression is equal to 1. So proved. Now problem 11. If x to the power a equal to x to the power b is equal to x to the power a equal to y to the power b is equal to z to the power c, and x y z equal to 1, then we have find the value of ab plus bc plus ca. So how to do? When we will have equation like this: x to the power a equal to y to the power b equal to z to the power c, then we will take a common term equal to these three terms. So we can write a solution given that x to the power a equal to x y to the power b equal to z to the power c, and x y z equal to 1. Let x to the power a plus y equal to y to the power b equal to y to z to the power c equal to k. Now x to the power a equal to k, y to the power b equal to k, and z to the power c equal to also k. So x to the power a equal to k gives us x equal to k to the power 1 by a, dividing the powers of both sides by a. Now also y to the power b is k, so we can write that y is equal to k to the power 1 by b. This is equation 2. Again z to the power c equal to k, or z equal to k to the power 1 by c. Now we have found the values of x, y and z. So if we multiply them, the equation 1, 2 and 3, we multiply the equation, then at the left side we will have x, y, z, and at the right side we will have k to the power 1 by a, k to the power 1 by b, and k to the power 1 by c. So let's see what happened. Now multiplying 1, 2 and 3, we will get x, y, z equal to k to the power a into k to the power b into k to the power c. So value of x, y, z is given 1. So 1 equal to k to the power 1 by a plus 1 by b plus 1 by c. So we can say that k to the power 0 equal to k to the power ab plus bc plus ca divided by abc by taking LCM and adding the fractions, or ab plus bc plus ca divided by abc equal to 0, or ab plus bc plus ca equal to 0. So this is the value of AB plus BC plus CA. We have to find the value of AB plus BC plus CA. So the value of AB plus BC plus CA is 0. So this is the answer. Oh, sorry, prove, not prove. This will be. So I hope you have understood the solved examples, and I recommend you to solve all the problems that are given in exercise 9.1, and also solve the examples by yourself. So guys, thank you for attending this class very carefully, and I hope you will be able to do all the other maths they are given in this chapter. And soon I will come with another video which will help you to solve the problems from logarithm chapter.